Welcome to lesson 3.1. The learning targets for today are to be able to identify the angles formed by two lines and a transversal, and be able to identify parallel, perpendicular, and skew lines. It begins by asking you just some guiding questions. Which angles do you think are on the interior of the figure? So we have this line and we have these lines, and then there's certain angles that tend to be inside of those. Inside of those we have 4, 3, 5, and 6, which do appear to be on the exterior, 1, 2, 8, and 7. Using the vocabulary words given in the left-hand column, decide which lines and or angles correspond to each to create a definition and why. Transversal. A transversal is a line that intersects two or more lines. Doesn't have to bisect them, doesn't have to do any of that in terms of segment, it just has to intersect two or more lines. So in this picture, we have three lines, M, N, and T. Only one of them is a transversal. For our picture, T is the transversal. Corresponding angles. Okay, so we have some different things. When we get into proofs later, we're going to talk about corresponding angles being the ones that match up between two shapes. But when we're talking about two intersecting lines and a transversal, all of these angles that we're going to talk about are formed by lines that are intersected by a transversal. And maybe there are two lines intersected by a transversal, or 3, or 4, or 5. But we're going to be talking about two lines intersected by a transversal creating these. So when two or more lines are intersected by a transversal, this will work. This will create the following sets of angles that we're going to look at. All four of those. Corresponding, alternate interior, alternate exterior, and same side interior. Corresponding angles are ones that when you look at them, they actually, you'll have one on the interior, okay? One on the interior, and one on the exterior. And they'll be on the same side of the transversal. Now there is a much more accurate definition for this, but what you need to be able to do is to identify them in a picture. We'll do proofs with them and we'll look at some theorems and postulates regarding these types of angle sets. But for now, your goal is to be able to identify them in a picture. So one's on the interior, one's on the exterior, and they're on the same side of the transversal. The angles that are on the same side of the transversal on the left are 1, 4, 5, and 8. Oh, also, one's on the interior, one's on the exterior, and they're not a linear pair. They have to touch two different lines. And they both touch the transversal. So we have our transversal here. Angle, let's look at the ones on the right side. The right side of the transversal are 2, 3, 6, and 7. So 6 and 7 are a linear pair, so they are not corresponding angles. But here's one on the outside, and here's one on the interior. They're touching different lines other than the transversal. They both touch the transversal. If I were to trace them, I wish I had a tool here to do this with, they would make the letter F. Between the 3 and the 7, they would make the letter F. So I would have, I'll do this in red and I'll have to go over it with darker colors later. There's angle 3, and here's angle 7. They're under the letter F. So when we're looking for corresponding angles, we're looking for an F shape when we trace the angles, and it would be under the corners of the F. Now, it's not just going to be an F, though. It could be a backwards F or an upside down F. So looking at this picture, our backwards F would be 4, angle 4 with angle 8. Angle 4 with angle 8 is our backwards facing F. So in this particular picture, our angles are angle 3 and 7, angle 4 and angle 8. There are 2 more sets of corresponding angles, 3 and 7, 4 and 8. We also look for the upside down F. The upside down F is if I use 6 and 2. So here's the top of the F. Here's the line going for the F in the bottom. So 6 and 2. Angle 6 and angle 2. And then the upside down backwards F, so here's the backwards F, flip it upside down, we're looking at angle 5, if this is now the top. And this is the bottom, I'm looking at angle 5 and angle 1. So there's my F, 5 and 1. If my software were working right now, I could trace that, but unfortunately I'm not able to. You know what, I might be able to in Microsoft Word though. Let me pause this. All right, we're gonna try this. Alternate interior angles are the ones that are formed. They actually are on alternate sides of the transversal and transversal and on the interior, and they have to be on the interior of the lines. And again, they cannot be linear pairs. So this will be alternate interior angles. I'm going to highlight these ones in yellow and write them as we go. There are only going to be 2 sets of alternate interior angles. So as I trace, so I have angle 4 is one that's inside. It can't be angle 3 with it because then it would be a linear pair. Has to be the alternate side of that transversal in the interior, so it's going to be 6. So it's actually angles 4 and 6. If I trace angle 4 and angle 6, I actually get a letter. I get the letter Z. So these are inside the letter Z. So that's what we're going to write down here, that these angles are under the letter Z. They're in the corners of the letter Z. And it could be a forward Z or a backward Z. But they'll be in the corners of the Z. So our angle pairs for this particular picture are 4 and 6, and 3 and 5. Angle 3 and angle 5 are both under that. So angle 3 and 5. So we have 4 and 6 and 3 and 5. Angle 4 and angle 6. Angle 3 and angle 5. Alternate exterior angles are on the outside of the Z, but it might be easier to identify them simply by looking for the exact wording. They're on alternate sides of the transversal, and they're on the exterior and exterior angles. So again, they can't be linear pairs, so not linear pairs. So I have people all the time who look and they say, well, look, Mr. Ritter, this right here, they say, look, 2 and 1 are both on the exterior. Yes, and they are on alternate sides of the transversal, but they're not. But they're a linear pair. So if I trace angle 1, there's angle 1. Here's angle 7. Okay. These are on alternate sides of the transversal, and they're on the outside. One's on this side of the outside, one's on the other side of the outside. They're not really vertical angles. They look kind of like it. 5 and 7 are vertical angles. 3 and 1 are vertical angles. They do kind of point toward each other, though, like vertical angles. But they don't even share a common vertex either, like the others. So we have one vertex here. For all these angle pairs, we have one of the vertices being here on the transversal and the other one being here on the transversal, on the two separate lines that the transversal connects. So in this case, we have angle 1 and angle 7 for alternate exterior, angle 1 and angle 7. And then the other set of alternate exterior are angles 2 and 8. Angle 2 and angle 8. Same side interior. I hope that you can see it, but they are going to be on the same side. So the formal definition for same side interior is that they are on the same side of the transversal and on the interior. And again, not linear pairs. So if I look at this, I'll look on the right side of the transversal to start. On the right side of the transversal, I have this angle, angle 3, and this angle, angle 6, that are on the same side. They each have vertices, different vertices, one being on line N, one being on line M. And when I connect them, they make the letter C. They are inside the letter C. So one way to look, for alternate interior, we're looking for inside the Z. For corresponding, we're looking for under the letter F. And for same side interior, we're looking for inside the letter C. So for our picture, that's angles 3 and 6. And we also have angle 4 is on the interior, angle 5 is in the interior. There's our letter C, angles 4 and 5. So we want to be very good at identifying these different types of angles, just as good as we are at identifying linear pairs and vertical angles. Identifying corresponding, they make the letter F. They're in the corners of the letter F. Alternate interior in the corners of the Z. Same side interior in the corners of the C. Alternate exterior kind of pointing toward each other on different sides of the transversal and on the outside of the picture. So take a moment to see if you can figure out which one of these are corresponding alternate interior, alternate exterior, and same side interior. Take a moment to pause the video and see if you can figure these ones out. For the first one, corresponding angles, letter A, they have to make the letter F. Well, angle 1 and angle 3 do that. So angles 1 and 3 are corresponding. There are actually 4 sets of corresponding angles in any picture that we have 2 lines intersected by a transversal. So the other F that you may have seen would have been 4 and 2. Yet another F that we could have gotten would be angles 5 and 7. And alternate, we're all not done. There's one last set. The final F you may have seen would have been those two. I need to erase, though, because I can't see them very well. 6 and 8. Angles 6 and 8. All right, for alternate interior angles, the alternate interior angles make the letter Z, and they're inside. So the angles that are inside are 2 and 7. And then the other set of alternate interior angles that make the Z are 3 and 6. So you could have had either one of those and had a correct answer. For alternate exterior angles, the exterior of this picture, the angles that are on the outside, are 1, 5, 4, and 8. And we need them to be on alternate sides of the transversal. So angle 1 with angle 8 are on alternate sides and on the exterior. The other set of alternate exterior are 5 and 4. So the numbers are going to change in the picture. The picture can change drastically. Even as we get to our next example, you'll see that. Same side interior, hopefully you're able to identify those. The same side interior angles are on the same side. They actually make the letter C. So those are both interior, and they're on the same side of the transversal. So angles 6 and 7, angles 6 and 7, and then the other side, the other set is angles 2 and 3. All right, let's take a look then at the next one. Identify the transversal and classify each angle pair. Remember, the transversal is a line that intersects two lines. In this picture, all lines, L, M, and N, intersect two other lines. So they are all transversals, but not for each angle pair. If you look back at the angles that we did above, when we were making our angle pairs, we were looking at this line and this line. Those were the vertices of our angles. This line and this line were intersected by this transversal, giving us these vertices for our angles. So the thing that you want to look at is the vertices that the vertices of the angles, and whatever line they're both on, that is your transversal. That's how we can identify the transversal, is to look at the vertices for the angles. So for letter A, they gave us angle 1 and angle 5. Both of those are on line N, angle 1 and 5. So I know that my transversal for this problem is T. Now, when I trace angle 1 and angle 5, I see a shape. I see a funky looking Z. I also know that if N is the transversal, then my exterior angles are here and here. And so angle 1 and 5 are actually on the interior, and they're on alternate sides of the transversal. So 1 and 5 are alternate interior angles. AIA is the abbreviation that we use for alternate interior angles. Next, I look at angles 3 and 6. Angle 3's vertex is there, angle 6 vertex is there. So this green line is going to be our transversal. Now I'm going to trace those angles. Here's angle 6, here's angle 3. Angle 6 and angle 3. Some of you see the letter right away. It's a funky shaped looking F. We're going to write our transversal as M down here. Now this is great, except some of you might not see it. So if I'm looking at the exterior, on the outside of this transversal is 4 and the angle next to it. On the outside is 6 and this angle next to it. So 3 is an interior and 6 is an exterior. The only angle pair that has both an exterior and an interior is corresponding. So these are corresponding angles. And we do need to write it out for now. We'll have a shortcut later, but not yet. So those are corresponding angles. Angles 1 and 4 are our next set. Give those a try. See if you can figure out 1 and 4 and 2 and 5. When I touch the vertices of angles 1 and 4, that means line L is my transversal. This is really annoying. So L is my transversal, and angle 1 is on the outside of the two lines that it's intersecting, and so is 4. And they're on alternate sides of the transversal. So 1 and 4 are alternate exterior angles. For our last one, hopefully you got this one right also, when I trace angle 2, or the vertex for 2 and the vertex for 5 are on transversal N. They're on transversal N, and when I trace 2 and I trace 5, they're both on the inside of the other two lines, and they're on the same side. They're actually inside the letter C. So the transversal is N, and angles 2 and 5 are same side interior, which we abbreviate SSIA for same side interior angles. From our previous lessons on lines, you know that parallel lines are two lines that never intersect. And have the same slope. They never intersect, which means they will actually have a different y-intercept. If they have the same y-intercept and the same slope, then it's one line, an overlapping line. There's a little bit more to this. Two lines that never intersect, and usually they're on the same plane, which you could connect pretty much any two lines. Well, not any, you will see in a second. Perpendicular lines are two lines, or are lines that intersect to form right angles. So we're going to look at some examples in here in a second. For parallel lines, by the way, we actually mark our parallel lines with double arrow marks. So I don't like, or an arrow mark actually, I don't like this picture very much, but this, if this is parallel to this, they would have arrows indicating that they are parallel. And if CD and GH are parallel, they're not parallel to AD and EH, so they'd actually have double arrows showing that they're parallel to each other and not to AD and EF. So if you're looking for parallel lines, you're looking for this, you're looking for arrows. And the symbol, if we're saying that, we would actually use 2 forward slashes for parallel. So in this statement right here, based on what I've shown in that picture, I could say that segment AD, which I'd have to put a bar over, and I will, is parallel to segment EH. I'm going to have to do my parallel line with this to save time. So AD is parallel to EH. Perpendicular lines are lines that intersect to form right angles, and there actually should be multiple sets in this problem. Because of the way it's drawn, it looks like a rectangular prism, but it may not be a rectangular prism. I'm not positive. So here's the thing. Actually, I am because of what is marked. We have this right angle, and it touches AB, and it touches AD. So anything that's not marked with a right angle, unless I have a way to prove it, the postulate, theorem, or definition, or something else to prove it, I cannot say that anything else or any other lines are perpendicular unless they have a right angle mark. So right now we have AB is perpendicular to AD. The symbol for perpendicular is an upside down T. So I have AB is perpendicular to AD. They should share a common vertex. BA and AD both share vertex A. There is one other one. This picture can be a little deceiving, so sometimes you got to be very careful with those. This right angle is right in that it's touching line EH and line AE. So in this case, we would say EA is perpendicular, or AE is perpendicular to EH. And using the mouse to do this is not my strong suit. Sorry about that. AE is perpendicular to AEH. Parallel planes are two planes that will never intersect. Two planes that will never intersect. And we're missing a definition on here that we need to talk about. Planes that will never intersect. So in this picture, It's not marked. We'd want to see parallel lines, so we knew that the lines of the planes were parallel. But it appears that this plane on top, ADC, which includes point B, is parallel to the plane on the bottom of the box. A little hard to draw with this, bear with me, EHGF. So the black is where you can't see it because they're overlapping. They're not really overlapping, but the colors are because it's a two-dimensional representation of a three-dimensional shape. I see what I skipped. I drew it right here. This is what I was worried about or thought we had skipped, but it's just because of where I wrote the perpendicular. Skew lines are lines that are neither, that will not intersect and are not parallel. They're lines that will not intersect and are not parallel, which means they can't be on the same plane. Because if they're on the same plane, then they're either going to have to intersect or they have to be parallel. So an example of that, oh, by the way, I didn't write this down for the last one. For my example of parallel planes would be plane ADC and plane EHG. You can name it with any three letters that are on that top or bottom plane. There are other planes that are probably parallel in this picture, but again, I don't have parallel lines to indicate that the lines are parallel, so it's hard to definitively say which planes are parallel. An example of skew lines, I can give you a three-dimensional example using the camera, and then I'll look at this two-dimensional example. So I have a textbook. I have our geometry textbook here. And with our geometry textbook, it has many edges, okay? So you can see that there's an edge down here that it's being represented with my red pen. And there's an edge up here being represented with my pink pen. Because they're on different planes, the planes that run parallel to each other, in fact, those lines will never intersect. They're not parallel either, though, okay? Now, this line connecting the top and bottom plane would intersect this red line. But this line up here is sitting above the other line, so they miss each other. They miss each other. If I give you a different view, they're not going to intersect. So when I'm looking at this picture, assuming that some of these planes might be parallel, line EH and line DC would be skew. Line EH would also be skew with AB because it wouldn't intersect it. But it has to come from one of the ones in the top plane that aren't parallel or don't even appear to be parallel to EH either. So for skew lines, we actually have EH skew with DC or AB based on that picture. And I have to put my bar on top because I'm not talking about their distance. Take a moment to try this for this picture. See if you can identify a pair of skew segments, a pair of parallel segments, a pair of perpendicular, and a pair of parallel planes. And I'll go over the answers as quickly as I can in just a second. All right, so that task is a little challenging given how many different things are in the picture. I probably should have given you one to base your answer off of. So those of you who are still going, I don't know what he wants me to do, why don't we make a skew off of FJ first? If I'm looking at FJ, the ones that would not be parallel to it is BE, okay? I don't want to be parallel, I want another plane. So ED or BC would be skew with FJ. So FJ and one of those. There are other combinations, and if you got something different and you're not sure, I will check it in class. I'm going to put FJ and ED are skew. But there are lots of other combinations, but they should be on two different planes, and when you look at them, they're not going to intersect. A pair of parallel segments, there tend to be a lot of those in this picture. We can have BF with EJ, or DH or CG. Any of those four are marked as parallel, so you can say they are parallel. There are other ones that I know will be parallel in these pictures, but we don't have enough to prove it right now. We haven't even started doing proofs with these shapes. So you can only go based on what's marked. So you can list any of those four that are in yellow. You may also list the ones that I have in pink separately. CD would be parallel to BE, to FJ, and to EH, because they are marked parallel. Any other sides other than those pink ones, or a set from the yellow, you cannot say without them being marked, unless you have a way to prove it, and we haven't done that yet. The only perpendicular segments in this picture, there's only one right angle marked, are BF and FJ. So you can only say BF and FJ for letter C. And make sure you put the bar on top. So BF and FJ are perpendicular. There's nothing else in this picture that's marked with a right angle. Now, because of the parallel lines, there will be other right angles. We haven't proven that yet, and if you're going to say that, you have to be able to justify it. Parallel planes. Because of the markings on the sides, it is pretty clear, or should be pretty clear, that this back plane, CDHG, is going to be parallel to this front plane, BEFJ. And you only need 3 letters to name a plane. So if you have plane BFJ and is parallel to plane CDH, or any combination of those letters for that back and front, then you're good. There are other planes that are parallel. They're hard to justify because we don't have the other sides, but this top plane of this prism and this bottom plane would be parallel too. So plane BED and FJH are also parallel. Even though we don't have enough parallel lines, or only one set of parallel lines to show it, you could have also said, because this is going to be a rectangular prism, EDH and BCG, those 2 side planes, would also be parallel planes. This concludes our notes for lesson 3.1. You want to make sure to go back to, well, actually, I don't think you can do your flipper yet, because those actually have to do with theorems, and we're not ready for that yet. But you want to make sure that you can identify transversals in pictures like this, and that you can know the difference between corresponding alternate interior, alternate exterior, and same side interior angles. Have a great day.